Okay, we're moving on to section 1.4 where we're going to study approximate linear relationships. So what we're going to see in this section is that real-life data often doesn't line up in a perfectly linear way, but still lines up roughly linear or approximately linear, and we're going to see how we deal with that. So let's look at an example. The median of a group of numbers is the number in the middle when the numbers are listed in order from smallest to largest. The median ages of cars in the U.S. is shown below for various years. Let A be the median age of the cars at T years since 1970. And the first thing they want us to do is to use the graphing calculator to decide on window settings. Now, if you look down a little bit, we're going to be drawing a scattergram, and so this idea of using the graphing calculator to decide window settings is really just an idea of let's use the graphing calculator as scratch work to kind of figure out how we're going to do our numbering. It's very easy to adjust a graph on the graphing calculator. It takes very little work to redo it, but when you're doing it by hand there's a lot of detail that goes in, so you really want to get it right on the first try. So we'll practice on the graphing calculator. Alright, so our years here start with 1970, but those are not actually the values of a variable. T is the number of years since 1970, so when they give me the actual years, the first thing I want to do is convert those over to the variable T. So I'm just going to draw a line in here, and then I'm going to put the variable T next to that. And I just need to take all of these and think how long has it been since 1970. So 1970 is our starting point, so no time has gone by yet, so that's a 0. 1975 is 5 years later. 1980 is 10 years later, and it looks like these are going up by 5, so this would be 15, 20, 25, 30, 35, and now we're just going up by 2 years, so this should be 37. And just to check that, since I kind of used pattern for a minute, let me go ahead and show the math on the calculator on that as well. So 2007 minus 1970, which is when we started the clock on this variable, gives us a difference of 37. So it looks like we held up all the way to the end and are still getting those right. Okay, so now I want to enter this data into the graphing calculator, and when we do that, we usually take our independent variable, which in this case is t, and enter those into L1, and then the median age over here is our variable a. So this is the variable a, and we'll go ahead and put those into L2. So we've done that before on the calculator, but I'll go ahead and show you those steps again. So the first thing is to get into the stat menu, and so to do that you want to use your stat button right here, so I'll press that. And then we want to edit data, so edit is already highlighted, so I can just press the enter key. And then it's fairly common to have some data sitting there already, so we want to clear that out. So just a reminder on those steps, use your arrow keys to go up and highlight the list name, so where it says L1 needs to be highlighted. And then you'll press clear, and you don't see anything vanish here, but down here it is now blank. And so if we press the down arrow or the enter key, that'll accept that clear, and now we have a blank there like we want. And now we can enter our values of t, so 0, 5, 10, etc. And then moving over into L2, we'll enter the values of A. Just a quick note here, there were some values that are out of order in the sense that it goes 6.9, then 6.5, then 7.7, so it got smaller and then bigger again, and then it started climbing. But don't switch those because these are ordered pairs, so that 6.5 needs to go with the 20, the 6.9 needs to go with the 15. We need to keep those lined up as ordered pairs. Alright, so our data is entered in. So we go and move this over. So now we want to start thinking about what our scale is going to be as far as the window goes. So we're going to press the window key right here, and we're going to start thinking about those settings. And actually, let me move this back over here for a minute. I apologize. I want to think about this data when I set up my window. So the t values go from 0 to 37. And so I could just put that 0 and 37 as my minimum and my max. But typically when you're doing that, you want to leave yourself a little extra room before the first one and after the last one. Otherwise, when you show your plot, it'll show up as a square and you won't see the whole square. So I'm going to go ahead and make my minimum -5, and the maximum I'm going to make 40. And I think it's worth a quick note here. Anytime you're entering a negative for something like the minimum, make sure you're using this negative key, not the subtraction key. This will give you an error message. You have to use the negative to get those negative signs. And then when we think about scale, if I'm going to go from -5 up to 40, then to me I feel like let's count in fives. So 0, 5, 10, 15, 20. When you're on the graphing calculator, the scale actually isn't that important of a number. And then we want to do our y values. Now the y values go from 4.9 to 9.2, so again I could start out by just typing those in. And if I do that again, I'd have that problem of not seeing the whole square. So I'm going to go to 4.5 and 9.5. And I could number in ones, I guess, but then I'm going 4.5, 5.5, 6.5. I'm going to number in 0.5s instead. And then that way I'm going 4.5, 5, 5.5, 6. I like that a little better. I get the whole numbers that way. And then before we go to look at our graph, let's just check our stat plot and make sure it's set up. So stat plot is right here. Notice that's above this key. So you're going to want to hit the second key and then get that stat plot. So second and stat plot. And this should be set up from previous problems we've done. But we want to make sure that plot 1 is on, that it's a scatter plot, that our lists are L1 and L2, and that we're plotting using a square. So it looks like everything's good there. So let me hit the graph button. So I like that. Looks like a pretty good picture of the data, and what I'm really looking for is that I don't have like too many tick marks where it's really tight. That would be a problem with scale. And I want my data to be spread out nicely in the vertical and the horizontal, and it looks like we've done a pretty good job of that. So I like that scale, so I'm going to go ahead and change back to the window setting, and I'm going to copy those down. So it looks like good settings on the graphing calculator here for the x minimum would be -5. For the x max would be 40. For the x scale we would have 5. And then for the y minimum we went with 4.5. The y maximum 9.5. And our y scale we used was 1/2 or 0.5. Now in the future, we'll probably focus just on these graphing calculator type of scatter plots, and that'll be our main focus. But for now, we want to learn to do them by hand as well. Okay, now we're moving on to part B, where they want us to draw a scattergram for the data by hand using the grid right over here, and they want us to allow room for the year 2020. Now it's fairly common for them to ask us to allow room for a year in the future like that because we're going to use our model to make predictions, so we want to leave a little room to go off into the future somewhat on that. So the first thing we need to figure out if we're going to allow room for the year 2020 is what would that be as a t-value, and I actually already calculated that here, but we would say that t is equal to the year 2020 that we're interested in minus the starting year of 1970, and that gives us a t-value of 50. So we're going to need to make sure that t equals 50 fits on our picture. So when we start making adjustments to things like this, it can affect how we draw things by hand. And also, when you draw things by hand, you don't necessarily have to allow extra room for the squares to show. So we're going to go ahead and make some adjustments for that. And I'm going to go ahead and start off here just by drawing in some axes, and then we'll use the graphing calculator to think about how we want to scale this and number this to make everything fit and be spread out nicely. And while I'm drawing these in, it's worth mentioning this is actually a step that people forget to do a lot when they're provided with graph grids. They just kind of take it for granted that the bottom is the horizontal axis and the far left is the vertical axis, but those do need to be drawn in, and they should be labeled as well. So this horizontal one will be my t-axis, and the vertical one would be the a-axis. Alright, so now we're going to want to plot these points, but before we do that on this grid, we're going to try and kind of arrange it on the graphing calculator so that we get it right in one try on the grid. So what we need to start considering now is the number of squares that we have here. So on this grid we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 squares on our horizontal, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 squares on our vertical. This is something that we didn't worry about on the graphing calculator, but when you're given a fixed piece of graph paper, you have to consider that now. And what determines that portion is the scale. So we're going to think about scale a little bit more carefully on the calculator and see if this 14 by 11 grid is going to fit with what we've already done. So let's go ahead and go back to the graphing calculator. Let's look at our window settings. So this is what we had set up before. And I want to check right now to see if this is going to make sense and if it's going to fit this value of t equals 50. Well, clearly it won't with a max of 40, but with 14 squares, my max wouldn't necessarily be at 40. And then the other thing is there's no need for that extra room, so I think I'm going to change that to a 0 now. Now when you want to think about what your maximum is going to be, you take your minimum and you add the number of squares you're going to have times the scale you're planning on using, which for us was a 5. And I'd really like to stay with that 5 if I can, because our data goes 0, 5, 10, 15, 20, and it'll make it easiest to graph if we use a scale that matches this sort of addition factor we have here. So with 14 squares, our max would actually be 70, so that would leave us room for that 50 with a little bit left over. So I think that'll work. We'll go with a minimum of 0, a maximum of 70, and a scale of 5. So let's go ahead and do that down here. So I'm going to go in 5s, but I don't like to number every one, so I'll number every other one. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. And that's actually the biggest one we're going to need, and then we have a little bit of extra room left over. And as long as it's just a little bit of extra room, that's fine. I'll go ahead and number that out to 70. So we can look at what that looks like on the calculator right now. And one of the problems with that is I think like this is, 40 right there, so 45, 50. If we were going to make a prediction for that and we went up to 50 and we thought, well, where would that be on the line? It'd be like up here somewhere off the screen. So I'm going to want to expand my window up to allow a little bit more data to show on the vertical. So that's where we need to start thinking about changes to our Y window. So we go back to the window, and let me think about right now what would my max be. I'm going from 4.5 to 9.5, and anytime you don't set your minimum at 0, I'll show you this in a minute on the grid, but you would have to leave a square blank. So that's actually going to take away one of our squares if we don't start at 0. So we're only going to have 10 squares to work with. And my Y max would be my minimum plus 10 squares times my scale, which would be 9.5, which is right what I have already. But the problem is we said we're going to probably need some extra room on this. So I think instead of using a scale of 0.5, we might want to round that up a little bit and go to a scale of 1. If we're going to do that, we might as well start at a nicer number like 4. And then our Y maximum would be 4 plus 10 squares times a scale of 1, and that would give 14. And that looks like that would be good because that'll give us the extra room we need. Let's look at it on the graph. Yeah, so we still have that same pattern, but now we have a little extra room out here where we could make some predictions, and they are asking us to do that, so it's good to leave that room. So that's what I'm going to do for my scale there. So let's look at that window. I'm going to start at 4, and I'm going to number in 1s, and that should get me up to 14. So I mentioned that if you're going to start at a number other than 0, you're going to kind of need an extra square. That's because we won't start the numbering on the bottom. We'll start it right here. If it was 0, I would start at the bottom, but if my Y minimum is something other than 0, I have to move it up a notch and then show that I've broken scale. And then I can number in 1s, 5, 6, 7, 8, 9, 10, 11, 12, and 13 and 14 shouldn't really come into play, but I'll go ahead and make those tick marks anyways. Alright, before we start plotting data, I just want to kind of point something out. We had this original scale that we listed, and I think this was a perfect scale for showing this data. Really spread it out nicely over the screen. But then when we went to go do it by hand on the grid, we made some changes. And since we made some changes, I think it's worth noting those as well. So when we switched over to the grid, we decided to go with a x minimum of 0 and x max of 70 using our scale of 5, and that was kind of forced on us by that 14 squares we had to work with. And then we decided to change our y scale to 1 because we needed a little extra room to make predictions. We changed our minimum to 4, and then we had 10 squares to work with, so that got us up to a y max of 14. So it's probably good to have both of those showing in your notes so that you can see kind of a consistency there. You can see what we did on the calculator alone, but then if we needed to make room for the year 2020, we made some adjustments to that. Alright, so now we want to move on and start plotting our points. So let's go ahead and do our ordered pairs. We have 0, 4.9, so over 0 up to 4.9. You don't have to worry about being perfect on these, but get as close as you can to what seems like a point of 4.9. And this is 4 and 5, so I want to be nice and close to that 5. The next one is over 5 and up to 5.4, so maybe just a little less than halfway from 5 to 6. And then over 10 up to 6. And over, let's see, our next one, 15 and 6.9. And then 20 and 6.5. So I'm sorry, this was 6.9, so 6.5 would be right about here. And then over to 25 up to 7.7. And over to 30 up to 8.3. And over to 35 we're at 9. And then at 37, which unfortunately is not a grid line, so we'll just do the best we can, and up to 9.2. And then let's just see how that looks compared to what we had on our calculator. And when I look at those two compared to each other, it seems like a pretty good match. Let's go ahead and make this one just a little bit darker. So there's our graph done both by hand and on the graphing calculator, and we use the graphing calculator to help with the setup there. Alright, moving on to part C. Are the variables t and a linearly related, approximately linearly related, or neither? Well, when I look at that graph, it looks to me like there's roughly a linear relationship. I can kind of imagine using the edge of my little ruler here, and it looks like the data roughly follows that. It's not perfectly linear for sure. I couldn't draw a line where it would hit all of those data values, but that line seems to kind of represent the pattern that's going on. So I would say these are approximately linearly related. Now draw a line that comes close to the points in your scattergram. So this is going to be our model. We're drawing a line that we're going to use to model what's going on here between the relationship of the of the years, number of years since 1970, and the median age of the cars that are on the road. So your strategy isn't to hit all the points. That's not possible. It's not to hit the first point and the last point. It's not necessarily even to hit any of the points. You just want to do something that really seems to follow the pattern. So I'm going to do something like this where it looks like I'll miss this one and miss that one, but kind of come close to most of the other ones. It's really nice to have kind of a clear ruler here so that if you are overlapping some of your points, you can kind of keep track of where those are. And one of the things that you have to just be aware of and kind of learn to be okay with is that we're all going to have a slightly different picture here. Even if you're copying what I'm doing on the video and you're trying to do this on your notes as best you can, it's going to look a little bit different. We will be able to remedy that later, but for now we're just drawing the best model we can. So I'm just going to put a check mark here because we've done that. That line is our model, and that's maybe worth writing down, making a note of. So the line is the model. So now they say, let's use the model to predict the median age of the cars in 2014. And was this an interpolation or an extrapolation? So first let's make just the prediction. So 2014, the first thing I want to do is figure out the value of t. 2014 minus 1970, that's 44. So that's the value of t that I want to use. So what I'm going to do is grab a different color here. I'm going to go onto my graph. 44 would be just a little bit short of that 45 tick mark. And I'm going to get as close as I can to that spot. And I'm going to draw up. And then I'm going to draw over. And based on what I've done there, I'd say it looks like when t is equal to 44, maybe the value of a is just slightly over 10. So I'm going to say it looks like t equals 44 implies that a is equal to 10.1. And then as far as the question of is this an interpolation or an extrapolation goes, we'll define that on the next page. But if the t value they give you is within the range of your given t values from 0 to 37, that would be an interpolation. When you get outside, our 44 is bigger than the biggest t value in our data set, now you're making an extrapolation. So I would say that 10.1, and probably since we're making that prediction, we should put units too. I would say it's 10.1 years old. And then I would also say this is an extrapolation. And the reason I would give is that it's outside of the range of the given ages, or years, sorry. So in our data set, we were given years from 0 to 37, and now all of a sudden we're plugging a 44 in. That's not within that range. All right, let's go ahead and look at part F. Use your model to predict when the median age of the cars was 8 years, and was this an interpolation or an extrapolation? I'm just going to go ahead and switch to another color here so that we can tell the difference between those. In fact, let me go ahead and mark this one in pink just so you can kind of see that. Alright, so when they say the median age was 8 years, they're giving us that A is equal to 8. And our A axis is the vertical axis. So I want to go to A equals 8. Draw across till I hit the graph. And then once I get that intersection, draw straight down from there. And that looks like 20, 25, 30, so maybe this is 26, maybe 27 years old. I'll go ahead and say a little closer to 26 maybe. So it looks like t equals 26. Now, I said 26 years old. Actually, this is a number of years since 1970. So if t is 26, then we have 1970 plus 26, which would be 1996. So that would be my prediction, is that it would be the year 1996 when the median age of the cars was 8 years old. And then was that an interpolation or an extrapolation? And explain. Well, t equals 26 is in the range of our given dots from 0 to 37, so this time it's an interpolation. And the reasoning there is that t equals 26 is in the given range. And that given range was from 0 to 37. Alright, let's go ahead and finish up section 1.4. In the previous example, we used the words interpolation and extrapolation, and I want to go ahead and give definitions of those here for you. So interpolation is when we make an estimate for the dependent variable, which is our output variable, using a value of the independent, which is our input variable, that is in the given range of the independent variables. So for example, in that previous problem, we had a t equals 26, which was in the range of the 0 to 37 values that we were given, so that was an interpolation. Extrapolation is when we make an estimate for the dependent variable using a value of the independent variable that is not in the given range of the independent variables. So on, let's see, was it part E, they asked us to make a prediction for the year 2014 that ended up being a t of 44, which was outside of that given range of 0 to 37, so that made that one an extrapolation. And the reason we point these out is that when you're making predictions, there's always a possibility that you're going to have a model that's going to work for a while, but then it might start making some predictions that actually don't make sense. So that's called model breakdown. So let's define that. When a model gives a prediction that does not make sense, or an estimate that is not a good approximation, we say that model breakdown has occurred. And the thing that we want to point out here is this is most likely to occur when we try to extrapolate.